Hi, we're going to take a look at Earth's atmosphere.
All of the events of the past decade, all of our memories, have something in common. They all took place during the hottest decade ever recorded since humans began keeping temperature records about 150 years ago. In the last decade, the Earth's temperature rose roughly a third of a degree Fahrenheit. Since 1880, it's risen about 1.5 degrees. You might say the Earth's running a fever, and scientists predict it's going to get much worse. Already, we can tally the signs. Global sea level rose by over an inch during the decade, almost twice as fast as the average during the 20th century. Arctic summer sea ice declined by over 300,000 square miles, enough ice to cover the states of Texas and Kentucky. The vast majority of climate scientists say evidence for human-caused warming is clear, but less understood is exactly how this warming will change the complex interactions between our planet's land, water, sky, and the living organisms that inhabit our world. As NASA scientists improve their understanding and predictions about climate change, NASA satellites provide critical data about what's happening on our planet today, real-life observations scientists use to hone their predictions. And NASA gets a global view of three major pieces of the climate puzzle: how much of the sun's energy is hitting the Earth, how much of that energy is reflected back out into space, and how much is being trapped, heating the planet. NASA satellites measure the sun's energy, which fluctuates due to a 10 to 12 year cycle. Could increased solar activity be causing global warming? Satellite evidence shows us that the solar cycle has only a slight impact on our planet's temperatures. In fact, even though the last few years have been some of the warmest on record, the sun has been in a deep lull in activity. That means slightly less solar energy has been reaching Earth. And when the solar cycle ramps up again, scientists expect temperatures will rise even a little more. A second piece of the temperature puzzle is our planet's brightness. All other things being equal, a brighter, more reflective planet bounces more energy back to space. Some of the brightest, most reflective areas of our planet are those covered with ice. NASA imagery shows those areas shrinking, especially in the Arctic. As sea ice vanishes into darker ocean, our planet becomes less reflective and warms even further. Clouds also reflect a lot of sunlight. As our planet warms, more water evaporates, potentially creating more clouds. More cloud cover increases the Earth's brightness, possibly helping to cool the planet. But clouds, and the small particles called aerosols that help them form, are climate wildcards. Many current climate models predict some cooling due to increased cloud cover. Will it be enough to significantly slow warming? Scientists are using NASA data to look for the answer. Further complicating the issue is that water vapor is actually the world's most abundant greenhouse gas. That's right, the same molecules that might cool the planet in cloud form actually warm it when they're in the form of a gas. They help create a blanket around the Earth, catching heat radiating from the planet's surface and trapping it within the atmosphere. As the planet warms, more water evaporates from the ocean, creating more of this heat-trapping greenhouse gas. Humans can't directly control the amount of water vapor in the air, but we can have a much greater impact on other major greenhouse gases. Carbon dioxide is the second most prevalent greenhouse gas, and it's our biggest contribution to global warming. Fossil fuel burning releases large amounts of carbon dioxide into the air. NASA satellite instruments capture the infrared signature of carbon dioxide in the global atmosphere. They show a rise throughout the decade. NASA also monitors other greenhouse gases, such as methane, nitrous oxide, and CFCs. In recent years, CFCs have decreased. Methane and nitrous oxide are on the rise. Greenhouse gas is most likely the main contributor to current global warming. It's the key piece of the temperature puzzle. and it's unlocked the door to higher and higher temperatures. In 2010, it marks the end of the hottest decade we've recorded so far. What will the next 10 years hold for the Earth's climate? Computer models predict an even warmer planet, with more extreme weather, less ice, and higher seas. The severity of those changes will depend partly on how our planet's complex system responds, and more importantly, on what choices we make.
This was a video from 10 years ago, and I apologize for yawning. I apparently should not do this at 1:45 in the morning, but I wanted to get this done for you. So we're going to really look now at, this was 10 years ago. It was the hottest decade on record, and that trend has continued. Australia, about 3 years ago, I want to say it was, actually had to create new temperature map color because they were consistently in the 100 and teens, and they hadn't had to create that color before. And as we know, this last year has been really hard on Australia and their fires. This is really looking at, this is from NASA, Climate 365, and it's comparing 4 different lines. The red is NASA's Goddard's Institute for Space Studies. The blue is Met Office Hadley Center Climate Research Unit. The greenish color is NOAA National Climate Data Center, and the purple is the Japanese Meteorological Agency. And all of their graphs are really trending pretty similar to each other. And what you're comparing in, here's what they say is there's disagreement on what's happening. Here is 2000, here's 1980, 1960. I know this is hard to see because I'm having a hard time and it's bigger on my computer. All the way back to 1900 and 1800s. And remember, we can get a lot of information from core samples, from the fact that for over 100 years we've been keeping temperature records. And we are seeing this correlation of temperature anomaly. It is normal to have cooler. It is normal to be warmer. But as we look past in ice core data and all these other sources that we have, it doesn't usually happen this fast. That's the difference. A long turnabout with the wobble of the Earth, those are normal cycles, and we should actually be getting colder according to that, and we are getting warmer. So let's talk about the atmosphere and how it interacts with us. Well, it carries particulate matter in the air, and particulates can be found in the air, can cause diseases and cancer. So if you have emphysema or asthma, a large number of particulate matters, they'll tell you to stay inside. Even in Minnesota now, we're having bad air days where they tell you if you're young or you're old or you have respiratory issues that you should not be going outside that day to walk or to exercise. So high level particulate matters can also block out the sun, stopping photosynthesis and kill plants. That's happened before, but usually it's a volcanic eruption. The last time was in the late 1800s. It was called the year without a summer. We had a volcanic eruption, and it put so much ash into the air that it kept our temperatures cooler, and there really wasn't a growing season that summer all around the world. So what puts particulate matter into the air? Well, wood smoke contributes almost a third of all of it. Cooking, a lot of the world still uses open fire cooking, even a little bit of natural gas. It's a little cleaner burning. It's better than wood. On-road vehicles are 23%, off-road machinery 20%, refining contributes 7%, power plants 3%, aircraft 3%, marine 1%, and then everything else you can kind of throw into that other category is about 3% of what's left. Ozone at lower levels in the troposphere is smog. It can kill plants and cause problems for people who have heart and lung issues. This is not fog. This is human-made smog. It's air pollution. And really that is that nitrous oxide plus VOCs helps to create some ozone at lower levels. Ozone in the higher levels, as we know, is really good. It's the ozone layer. It's our Earth's natural sunscreen. We need it. Ozone lower where we live, not so good. So we don't like ozone down in the troposphere. It's bad for us. So if we look at sulfur oxide, they come from industrial smoke, and nitrous oxide causes acid rains and leads to death of plants and animals. Basically, this is our acid rain. factories, cars, all the things that put pollution, put it up into the air where it mixes with the water, creating slightly acidic conditions. Okay, so let's take a look at what happens when acid rain hits our world. It can actually cause pine trees to lose their needles. They become defaced. They just literally go down. It can kill fish if it causes acidity in the rain. And this, you may have to look in the notes, but you can see we're losing the definition on this line. This was from about 1912. This was 1969. We were already losing it. And this is within about the last 15 years. She had definition on her clothes and her face. Marble and acids don't mix. Remember when we, in 8th grade, if you were with Mr. Cater and myself, you put a little acid on calcium carbonate and it fizzed. And that's what's essentially happening when these statues are left outside. The slightly acidic rain dulls the marble. And here you can see the change in definition as you're starting to lose it. Heavy metals are also a huge issue as it goes up into our water system in our atmosphere and comes down in rain and causes issues like with mercury. It's released by burning coal, but it causes brain damage and mental illness. We laughed at the Mad Hatter and Alice in Wonderland, but really what was happening is hatters went mad, and they're like, those poor families, the son, luckily the father had enough time to train the son to take over the family business, because that family has this history that by the time they're in their 30s or 40s, they just start to lose their mind. And it happens generation after generation. Well, what was happening is in the felting process, they would dip their material into this solution, which contained mercury. And over enough exposure, they actually ended up with mercury poisoning, causing the mental illness. Lead paints and mercury is still an issue in our waters. We have recommendations for how often we eat fish, and there are some lakes that literally have contamination warnings that you should not eat a fish out of that lake because they will contain high levels of mercury. And mercury and lead are some of those things that it's a heavy metal. It doesn't really leave your system. Once it's in, it's just kind of there, and you just keep adding to it. Lead is found in old paints. That's why you have to do lead tests on a lot of buildings, especially older, if you're going to do construction. Pipe, that's supposed to be pipes and chemical products, but this causes brain damage and very severe developmental problems. If this comes in like a young child putting their mouth on a window ledge that has lead paint, can cause severe issues, loss of developmental skills, behavior attention problems, hearing loss, kidney damage, reduced IQ, slow body growth. If you look at the brain of a lead poisoned individual versus a normal brain, you can actually see a difference there. Symptoms will be headaches, irritability, reduced sensation, aggressive behavior, difficulty sleeping, abdominal pain, poor appetite, constipation, and anemia. It's not something you really want. And VOCs, volatile organic compounds found in paints, cleaners, cosmetics, pesticides, fertilizers, oil, and gas cause brain damage, cancer, birth defects. VOCs have really reduced since the 70s. Here's a little more about VOCs, but we still have them.
Volatile organic compounds, also known as VOCs, include a wide variety of chemicals in use today. VOCs are emitted as gases from certain solids or liquids, and many are known to have potential adverse health effects for people exposed to these compounds in the air they breathe. Concentrations of many VOCs are consistently higher indoors than outdoors, since they are emitted by a wide array of products found in most homes and buildings. Examples of common VOC sources include paints, paint strippers, and other solvents, wood preservatives, aerosol sprays.
So you have to use that in well-ventilated areas.
Pesticides, air fresheners, stored fuels and automotive products, hobby supplies, dry clean clothing, building materials and furnishings, glues, and adhesives. The ability of organic chemicals to cause health effects varies greatly from those that are highly toxic to those with no known health effect. As with other pollutants, the extent and nature of the health effects depend on many factors, including the level of exposure and length of time exposed. Eye and respiratory tract irritation, headaches, dizziness, visual disorders, and memory impairment are among the immediate symptoms that some people have experienced soon after exposure to small organics. Many organic compounds are known to cause cancer in animals. Some are suspected of causing or are known to cause cancer in humans. According to the U.S. Environmental Protection Agency, studies have found that levels of several organics average 2 to 5 times higher indoors than outdoors. During and for several hours immediately after certain activities, such as paint stripping, levels may be 1,000 times background outdoor levels.
You want to do that
Many
when you can open the
industrial
windows and
processes
have fans and blow fresh
manufacturing
air through.
facilities also use a wide range of VOCs during their daily activities. Occupational health and safety professionals are trained to assess workplace contaminants and associated worker exposures to comply with various regulations and to protect workers. There are also indoor air quality professionals who provide VOC testing services.
Okay, so that's the basics on VOC. If you want to watch the rest of that video, you are welcome to. It's in the notes. But it's that new plastic smell. Those are VOCs. If you have like new furniture that's off gassing, you might want to make sure you maybe leave it in a room where you're not going to be for that first week or so and let it off gas. And if it can do it so in the summer and open some windows, that will help too. Pollution solutions. So we have a lot of things that can cause solutions, or problems, but we also have the ability to make things better. Car emissions, switching to an electric, hybrid, hydrogen, or natural gas vehicle. I have a hybrid. It's reduced my carbon footprint a lot. I wanted to go all electric, but because of how I drive, it didn't quite make sense yet, and we don't quite have the infrastructure. But I'm hoping by the time you're my age, that won't be the reason why you make a decision one way or the other. In fact, you may be forced into electric vehicles by the time you're my age. I have a feeling that's on its way. We've created cars with better mileage. Industry and power switches alternative energies. A lot of businesses, including IKEA by the airport, has a huge solar panel on its roof. Costco in Eden Prairie actually has uh, skylights, and there are sensors on the lights that measure how much natural light's coming in. And if you ever pay attention, if you happen to go there, you'll notice that during the day, if it's really sunny out, some of the lights on the ceiling will actually be turned off. But on a cloudy day, you can actually see lights going on and off as it changes the amount of light coming in. So we can do things, and businesses are, because it makes sense for them. This isn't a commercial for FedEx. I'm not trying to promote it, but they were one of the first people more than a decade ago to really start looking at this and implementing it to make it better for themselves. And this is in China. There's another video that I couldn't find a really good YouTube link to it, and it shows that there's not plants, FedEx sort facilities that the whole roof is electric, and it drastically reduces their electric cost. Now, what you're going to find is, as we get into alternative energies, that we're really predicting that we're not going to be putting like power plants out of business, but we can rechange the direction we go. In fact, Hawaii, and it's right here, actually has a mandate that all new single-family dwellings built in the state of Hawaii are required to have solar water heaters. If it's a solar water heater is not installed, a variance from the state is required. And you need to basically, for the building plans to go through, you have to do that because Hawaii imports so much of their energy. They really have to look at how to be more self-sufficient. Home energy use. Some things that you can do in your home are just get more efficient appliances when you go to replace them. Solar on housing is becoming much more common. As I'm looking at building my house in hopefully the next 5 years, I've actually budgeted into the mortgage solar and geothermal, and hoping by then it's even come down farther in price, because I will then not have, I would still be tied to the grid, but as supplement as needed. And it would reduce my electricity bill. I have a fixed energy rate. And if you're my age or younger, you're going to be looking at a house someday, and maybe you've got a choice between two houses. One that's a traditional house that maybe uses $200 to $400 a month in energy, depending on how efficiently you're insulated and what time of the year it is. Are you running the air conditioner? Are you running the furnace? What are you doing? Or maybe even a same priced house that has 10-year-old solar panels on it, that's going to drastically reduce some of your income, your need for income to go towards bills and towards other things. And if you like them equally, solar panels usually have a pretty effective 25-year lifespan. That might be something you have to take into account. If one's more efficient than the other and you like them just as well, the location's just as good, pick the house that's going to cost you less money. And the last thing we're going to talk about is recycling. And we'll talk about this kind of continually through here to the end of the year. That reduce, reuse, recycle. It takes energy to make all of our products. So if you can reduce what you need, I did that at work. I stopped getting the water bottles, and I just get one big reusable 5-gallon bottle, and I bring it back in. I go back and recycle it and get a new one. And I'm not trying to, I always recycled my plastic bottles, don't get me wrong, but I'm trying to reduce my impact. If you have old clothing, instead of throwing it out, which takes decades for that stuff to decompose, donate it to someone else. You can do things like that. Give it another purpose, another life. And when you're in my class in recycling, I have 7 sinks. If you have a bottle, go dump it out and then recycle it, because they won't recycle stuff that has liquids in it because they can't guarantee what that liquid is. So you be smart about your recycling. Don't throw in food and contaminate it, because somebody has to sort that stuff. So here's my goal. I really hope that your generation does better than my generation did. And I think you will. I think we're making strides. This is looking at some temperature anomalies. So we're really looking at what this is showing temperature changes from the 1880s to last year. Let's take a quick look. And this has to do with really looking at what we as a society are doing to change our temperature, from VOCs to carbon to nitrous oxide to ozone. Now we're into the 70s and 80s, and we're seeing more and more yellows. And now we're getting into the 2000s, and we're seeing oranges and reds as pretty dominant. That's an interesting trend. So, what does NASA think that what we're going to be like in our future? Here we go. Up to 2030.
NASA has studied our home planet for more than 40 years, from space, in the air, and on the ground. The next 20 years will see a revolution in Earth science. Emerging technologies will enable new measurements to reveal the complex interactions among Earth's natural systems. Observations will be more efficient, and models improved for forecasting weather, climate, and natural hazards. This knowledge will help us better understand and predict hurricanes, earthquakes, and climate change. It will lead to practical applications to improve the quality of our lives. Today, NASA flies multiple spacecraft around Earth. In the future, we will have many more distributed observations. Underwater capabilities will look at ocean circulation, currents, temperatures, and salinity. UAVs, or uninhabited aerial vehicles, will validate and augment the data captured in space. New LiDAR instruments will measure 3D winds, cloud heights, and ocean turbulence, as well as vegetation and chemical effects. Space-based radar will be able to monitor changes in stress on major earthquake events, as well as soil moisture and cloud dynamics. And other systems, such as radiometers and spectrometers, will provide global measurements of Earth's atmosphere, land, and oceans with unprecedented resolution. Hundreds of small satellites, flying in formation or maneuvering with respect to each other, will track time-critical events. They could simulate a large aperture for very high-resolution measurements without a large satellite. Using high-resolution ensemble models will enable us to better predict the severity of storms and the best and worst-case scenarios. We'll be able to predict how much rain will fall and when, 7 to 14 days before it actually happens. And we'll be able to observe and even predict earthquakes, volcanic eruptions, and tsunamis. Formation-flying satellites will have the ability to reconfigure on the fly to watch these events evolve. Constellations of complementary satellites with different capabilities will work together autonomously. That means if one satellite fails, another will be able to replace or repair it.
Isn't that cool what could happen?
Provide an internet in space to exchange information, to command one another, and download data to users and decision supporters in a timely manner. Different vantage points will provide vertically and horizontally resolved measurements. High-resolution optical and infrared sensors on satellites will be placed in stable orbits at the Lagrange points. This will allow measurements of variables like clouds, water vapor, ozone, and aerosols under constant sunlit conditions over broad geographic areas. All this additional data will require large-scale exascale computers to solve billions of operations in a second. These computers, coupled with various types of models, will allow us to visualize and understand the interactions among Earth's systems. Complementary and comparative measurements will provide global, regional, and local scale data points. NASA won't do all this work alone. Many missions are international partnerships between multiple nations. And when the data are shared and compiled among the international community, it will allow us to better understand, predict, track, monitor, respond, and plan. This is our vision for the future, a vision that harnesses technology to create knowledge and to improve the quality of our lives.
Thank you for watching the notes. Have a good day.